Over the last year, we've seen the most extraordinary shutdown of the global economy in history. And ironically, this was not done because of the messaging around the crisis of global warming and climate change and extinction of species. It wasn't even around the collapse of human health, the rise of chronic disease, the possible extinction of our species. What inspired this shutdown of the world was fear of a virus. And so I want to take you for a moment into the world of the virome. The virome is a description of this vast genomic database that covers the world and has since the beginning of life on Earth. In fact, as we start to dive into the virome, I think we're going to discover that, in fact, we come from the virome. We are not in conflict with it. It's not here to attack us. It is here for our ultimate regenerative, adaptive capacity as life forms on this planet. The virome is an important distinction from the microbiome. The microbiome describes the large ecosystem beneath our feet in the soils, within the air we breathe, within the water systems of the planet, that is composed of living organisms. In fact, the term microbiome means tiny life forms. And so the microbiome has been miscategorized often as including these viruses. Viruses should not be compartmentalized within this description of the microbiome because, in fact, they're not living organisms. The virome is genomic information that's secreted from bacteria, fungi, multicellular plant life, humans, and beyond. And so life is exuding this genomic information. And in fact, as we start to dive into the genomics of human biology, we start to realize that this viral database that's in and around us in the environment is actually building life as we understand it today. If we look just at the human genomic system, we have about 20,000 human genes. But these are not unique to humans. In fact, we are 99% identical to nearly every other mammal on the planet. For example, if you take the human genome and clip it into 178 puzzle pieces, not eliminating any single base pair from our whole genome, you can rearrange that 178 puzzle pieces and build the entire genome of the pig down to the base pair. We are so similar to these other life forms on the planet, and it turns out that those are not unique to humans or pigs or mammals as a whole, but actually, again, are part of a large building block system that has come out of the virome in the last few decades of realization. What we are now seeing is that over 50% of those 20,000 genes that make up the human or the pig, more than 50% are made up from viral inserts into our genome. And so viruses don't attack us, they don't take over the apparatus of our cells, they actually are available to genomic updates. Not every virus that enters your system is going to be absorbed into that genomic code. In fact, it's a small fraction that become relevant to the human genome. The body, whether human or otherwise, is always looking for adaptive and regenerative qualities. And so as we start to see which genes are picked up, we start to see this constant improvement of function, this modality of adaptation through the genomic communication of the virome. With more than 50% of the human genes from viral insert, we can start to tease out different variations within that. We now know that 10% of the human genome, at least, is inserted directly by retroviruses, viruses such as HIV in this category. And so these are very critical genes to human function. In fact, the placenta and its formation is reliant upon a retrovirus gene insert that happened in mammals millions of years ago. We would not have had the emergence of mammals and the mammalian birth that is so unique from other life forms without the genomic insert of a retrovirus. Similarly, we wouldn't have a stem cell in its function without a viral insert. An RNA virus, millions of years ago, inserts itself into that emerging mammalian genome to allow for a stem cell to start to slide its expression across the usual bumper blocks of the predetermined cell type. In a typical cell, the whole genome is capable of expressing liver cell, kidney cell, or the rest, but a liver cell is always put between the bumper blocks of liver cell production, liver cell identity. The stem cell, because of the introduction of a retrovirus RNA strand, is allowed to start to slide its transcription across those bumper blocks and make any type of cell in the body. This is the definition of a pluripotent stem cell. And so from the placenta and mammalian birth to the regenerative capacity of stem cells, we are reliant upon the genomic information that we received from the virome. It's important that you and I start to change our perspective on the virome, because we've, for over 100 years, been making the mistake of attributing the same germ theory and changes that we see within the microbiome, the bacteria and the fungi, to these viruses, as if they were living life forms that can make biologic decisions or biologic adaptation like a bacteria or fungi can. And so the viruses are unique in that they're not alive. They are just genomic information wrapped up in a protein envelope that then can be delivered to a specific target. This is the differentiation between viruses and what we call exosomes. Exosomes, it turns out, are little packets of genomic information, both large information of RNA and DNA size, all the way down to microRNA, which are tiny little fragments of genetic information that are allowed to travel outside of our bodies to modify the behavior of organisms around us. And so extraordinarily, I'm exuding a bunch of exosome information all the time that's giving information to those around me, whether bacteria, fungi, or other humans, as to which genes I'm turning on in response to my environment. So if I'm stressed, toxic load, psychological stress, lack of sleep, any of these things, I start to exude stress signal into my microRNA exosome information, which will modify the behavior of the genes and organisms around me. That information can be absorbed by any cell. The exosomes are non-specific delivery systems, non-specific information stream flowing out of me. In contrast, the viruses are highly specific in their targeting. This is much more like a UPS driver who's going to go pick up a package, knows exactly which address it's going to deliver it to, with a specific function or purpose to that gift that you're sending to that target. In the same way, viruses will coat themselves with protein signaling system, or an address at which it needs to attach to a neighboring organism or some distant life form around the planet. And so in the case of coronavirus, for example, which has been made famous by this recent pandemic, there's a very specific receptor within the lung that's capable of taking up that specific genomic information of the coronavirus. That receptor is called the ACE2 receptor. And the ACE2 receptor expressed in our lung also happens to be expressed in other tissues. Most importantly, perhaps, our vascular system, as well as components within our blood system. White blood cells, red blood cells having components of potential interface with these ACE2 receptors. And so as the ACE2 receptors start to interact with this genomic packet of information, it can take that genetics up and decide whether it's useful as an update or not. It's important to understand why this package is being sent out in the first place. Viruses are being exuded from bacteria, fungi, and multicellular life like humans in response to stressors. And so if life is good and there's no reason for adaptation, then there's no reason for a lot of exosome or viral exudation from our body. Instead, when we get stressed, we start to trigger the need for adaptation and a change in response to that environment so that we can detox more effectively or prepare for repair and regeneration differently. And so this is why we start to exude these things. As such, it was very easy for me in the last few years to demonstrate in the study of agriculture where we would see the next epidemics of disease stem out of, because we can show the level of stress at the planetary level through our human behavior in the food, water, and air and transportation energy systems. Pollution of our soil systems with antimicrobials, the herbicides, then the pesticides, and then things like air pollution from traffic or energy production, putting carbon particulate into the atmosphere, starts to radically change the stress level of the organisms therein. And so Hubei province turns out to be the epicenter of this stress on the planet. The highest levels of agricultural spraying of glyphosate and other herbicides and pesticides are in that central Chinese district, and then we can start to see a simultaneous stress from pork production. The highest levels of swine factory production in the world is also centered in the same spot. As you start to stress the soil systems and therefore the food system that is going into those swine, so the grains and corn and other compounds that are going into that animal feed start to be this antimicrobial and stress-inducing effect on the swine. In that factory setting, the swine are exuding bacteria, fungi, and the rest that are starting to go into an extinction stress level with so much antimicrobial pressure. And so the stool from those swine is actually illegal to transport across state lines in the United States and other places around the world because it's such a biohazard, is then pooled in these large lakes of stool outside of the swine facilities in Hubei province. And in there are quadrillions and quadrillions of viral transfection and viral mutations happening as the stress level percolates up in that level in that biodiversity of the organisms, or perhaps the failing biodiversity within those organisms represented in the stool of those animals. And so you could see Hubei as a soil, animal production, stool mess of stress. And in that we expect a massive amount of viral signaling to be happening. The viruses are always exuding genomic variation, looking for adaptation. There's been a lot of focus on the possibility that a military lab or something else was involved in the creation of this virus, but I hold that it's unlikely that any lab in the world can produce as many viral variants and as much genomic variability and adaptation than a pile of pig stool. That pig stool, in its stress level, is going to be exuding so much information in so many different variants, and only a small segment will become biologically relevant. But at some point you see a genomic upgrade targeted at the right human target, that we will start to take that genomic information up, and then if we choose to, we will start to replicate that. So as you've seen with this recent pandemic, most people who are exposed are asymptomatic or mildly symptomatic, and yet they will go on to integrate some level of this genetic code into their production system at the cellular level. They can pass that information throughout their own body, and they can pass it to other humans in the environment to pass on that genomic variation, that genomic adaptation capacity. It's not surprising in the end that as we study influenza and other viruses that go pandemic every year, we find out that there's a human resilience factor that happens after exposure to these viruses. It looks to be a really important part of our machinery of repair and regeneration to have this experience of new genomic information in, our body sorting out its new relevance to our system. If our system is out of balance or our terrain has changed, we can be in an abnormal relationship to that genetic information, and that can induce fever and different forms of illness, that would cascade down from that inflammatory reaction that can happen as your immune system gets over-revved. But nonetheless, that genomic update then leads to this global resilience. And so influenza being a good example again, if we see somebody be infected with influenza, the following year they are resilient to many different organisms, not just the genetic information of the virome, but they start to become resilient against bacterial pneumonias and other complex biologic degradations. And so the intelligence that we see with this kind of update of genomic information, and even if it's the induction of fever and the appearance of illness, is updating the human immune system as to what are the possible threats and what are the resilience measures and what are the adaptation effects that you can adopt from that. So the following year, we'll see decreases in other viral infections in that host that was exposed to influenza. If we don't allow that individual to have a normal interaction with that viral update that goes around the planet every year, such as we give a flu vaccine, for example, and that interrupts this normal genomic update, this normal genomic homeogenesis or homeostasis balance effect that we should have every year with the virome, once disrupted, we start to see an increase in risk in things like coronavirus and other airborne agents of genomic information as we create an imbalance in our immune response to the genomics of a vast number of viruses and ultimately bacteria and bacteriophage, which are the viruses coming out of those bacteria. And so we're starting to really need this adaptation of our mindset. Ultimately, we need to come to terms with the fact that the virome is the source of life on the planet. It has helped with the adaptation and biodiversification of everything from plant life to animal life to ultimately human experience. And in that, it's not our enemy. It is impossible, in fact, that the viruses are against us, even if we just consider it by sheer number. forget all of the complex chemistry and biocellular events underneath the surface and start to just consider the ecosystem of the virome. In the air that I am breathing right now, there's an estimated 10 to the 31 viruses covering the planet. In the ocean water, 10 to the 31 viruses. In the soils of the earth, 10 to the 30 viruses. And so we're seeing that there's a literal continuum of genomic information running from the dirt into the water, and from the water into the air, that is exploding with genomic information from vast output systems of bacteria, fungi, and multicellular life around the planet. In that 10 to the 31 viruses, it's impossible to wrap your head around how much genomic information that is. But to put it in perspective, that's 10 million times more than our stars in the entire universe, just in the air. 10 million times more than our stars in the universe just in the seawater. 10 to the 30 viruses in the soil. So you're starting to see that if this was against us, if this genomic information could actually attack a human system and take over its apparatus of DNA and RNA synthesis, as we've been told, we would be so busy replicating viruses, we would have no time to do any human genomics. And so we have to come to terms with the fact that the body has been in a state of balance, ultimately, with the virome since our origin. If we look back through history at moments of pandemics or epidemic viral events, whether it's bubonic plague or the famous Spanish flu or the influenza of 1917 or this recent pandemic that we saw with coronavirus, what we need to ask is not which virus is attacking us, this is impossible, but instead what has changed in the terrain of the human experience that's changing our relationship to these viruses. In the case of polio, this is an interesting one. When we change the quality of water that we bathe in, we become prone to this virus that we call polio. That virus is not attacking the human, it's simply been put in an abnormal relationship to the human receptors and to the human immune system as the environment of the water system becomes contaminated and lacking the biodiversity and balance that it would have had in a natural state. And so with each of these, whether it be bubonic plague or polio or today's coronavirus pandemic, we can be sure that we've disrupted a fundamental relationship between the virome and the human experience. So how do we do that? There's a number of different ways that we see the human environment or the human balance system with this virome shift. One of them is in the change in the receptors for that genomic information. We see that pharmacology, with statin drugs and ACE inhibitors being two classes of common medications used for cholesterol management and blood pressure management, both upregulate to abnormal levels the ACE2 receptor by which the coronavirus, for example, enters the body. And so at that point, we've done something nature never intended, which is we could overwhelm the human bloodstream with this genomic information at too high of a concentration, overwhelming the usual mechanisms of balance. Furthermore, through chemical agriculture and the induction of glyphosate, which is the common ingredient in Roundup, we can perturb again our relationship to that viral load by the disruption of enzyme metabolism or enzyme production. One of these critical enzymes is ApoE3, and this enzyme is responsible for chopping up the DNA and RNA of viruses as they come into the human system. So if we're seeing too much genomic input, we can just cut up that DNA before it ever goes into a replication state, or during the replication state, we can shut it down, the proliferation, by upregulating these enzymes. Importantly, these enzymes have high glycine residues in them, and glycine is a critical amino acid that is undermined by the proverbial presence of glyphosate in our food and water systems. So by the pharmaceuticalization of people with cardiovascular disease, diabetes, kidney disease, which happen to be the top 3 comorbidities that put people at risk from dying from coronavirus, for example, we can screw up that train as to how we interact with that genomic update. Furthermore, if our food system is contaminated with glyphosate, if our water system is contaminated, we can undermine those enzymes that would then cleave the DNA and RNA, putting us into a balanced state. And so I believe it's through broad contamination of water systems and food systems, soil systems, and the pharmaceuticalization of the chronic diseases that would then come out of those poor nutritional states that we've produced this extremely abnormal relationship to a virus that's been around for many, many hundreds of years. And so the coronavirus went through an adaptation event through stress in the environment. With that stress signal going into the environment, most organisms will see that, update their genomic experience, their immune system balance, their enzyme homeostasis with that genomic information, and go on to live a more resilient and more regenerative life. Then in a very small segment of people, we'll see this severe disorder develop downstream, which seems to be at the front side a misbalance or a disequilibrium with that genomic information as it's delivered in abnormal doses and in an unregulated form to cause some overwhelm to the immune system. The immune system, as it gets revved up, can create an acute inflammatory, then chronic inflammatory experience that can have cascading effects long after the virus is gone. One of the most extraordinary scientific discoveries around the virome is the speed at which we're constantly coming into balance with this genetic information. An example of this is in the newborn. In a 7-day-old newborn, we see 10 to the 8th viruses in every gram of stool. This is before the child has an innate immune system. That child's not making its own antibodies yet and the rest, and yet already it's in this massive, extraordinary viromic stew of information that it's in balance with. The child's not getting sick at all at day 7 because it's got all of these enzymatic mechanisms within the cells to stay in a balanced state. The cells, in their resilience of protein production, enzyme production, and the rest, know how to chop up that genomic information such that it either regulates the initial production or regulates the downstream reproduction of that viral genomics, always coming into balance. When we see new viral content coming into the body, that might even be correlated with an acute inflammatory reaction that we call an illness. When we see that happen, within 3 days, we come into balance with that genomic information and we eliminate the overwhelming signal of that genome within our bloodstream. And so even in these most severe cases with this recent pandemic where we see people ultimately die, their bloodstream has long cleared the virus, has long come into complete genetic balance with that initial information stream by the time they're really elucidating the complications of the downstream illnesses that might then go on to threaten their lives. In that, we need to come to terms with the fact that nobody's died of coronavirus worldwide. By the time anybody's dying, which typically happens, anywhere from 2 weeks to 30 days after initial exposure, but even in the rapid times, it's 5 to 7 days within initial symptom onset. The virus is typically peaking on the first day, and then by day 2 and 3 of symptoms is already eradicated from the bloodstream. And so the speed at which we adopt this genetic information and move on suggests that that's not the primary problem. The problem that would lead to real illness, dysfunction, and ultimately disease and potential death is in the downstream consequences of the immune system getting revved up, the immune system adapting to this shift in biology. If there's not enough adaptive and injury response system available to this downstream events, we can see deep physiologic imbalances happen, we can see hypercoagulable states, we can see blood clots, we can see all kinds of dysfunction happen downstream. But it's only in that downstream human dysfunction state that we would see the risks of chronic disease illuminating the opportunity for opportunistic secondary pneumonias and the like that will happen in the hospital and ultimately cause respiratory death. Coronavirus, it's important to recognize, doesn't cause respiratory failure. This was seen back as far as SARS. In SARS in 2002, it was recognized that these patients were showing up hypoxic and then with no fluid in the lungs, no signs of respiratory failure. And then a few days later, if there was no reversal of the hypoxia, they would see fluid start to accumulate in the lung, which happens to be the same thing that happens when we get exposed to a low oxygen state at high altitudes or from other deprivations of oxygen like near drownings. In these situations, the lung starts to produce fluid within the air spaces in reaction to the hypoxic injury, not as a cause of the hypoxic injury. In those couple days, 3-5 days later, when the fluid starts to accumulate in the lung, it can be a natus for bacterial infection to set up, and you see secondary pneumonias and ultimately something called acute respiratory distress syndrome, where you kind of see a whiteout on X-ray or CT scan of all the lung fields as the fluid starts to accumulate bacterial colonization. ARDS has a very high mortality rate, which is exactly what we saw with SARS or coronavirus once they were in the ICU setting. But outside of the ICU setting, we can see the very low mortality rate across the population. Again, majority of people either asymptomatic or slightly symptomatic, maybe a cough, maybe some fatigue for a few days, and then it's gone. It only takes that 3 days to come into homeostatic balance with that. And if you've got all that antioxidant and reservoir of adaptation and response systems available, you'll clear that genomics without any downstream consequences. So for these few patients that are showing up with hypoxia as an initial presenting symptom, we have to ask what's going on there. It turns out that these patients that are presenting blue, hypoxic, before their lungs fill with fluid, are again in a characteristic distribution across the planet. And we see these people in high areas of air pollution. And it turns out that for over a decade now, we've recognized that air pollution can bind to viruses. And so PM 2.5 describes particulate matter of 2.5 microns or smaller that are suspended in the air around us. And amazingly, with the recent coronavirus, we see that for every micron, which is a very, very tiny amount of this particulate matter in the air, for every micron within cubic meter of air breathed, we see a 15 times more mortality for that individual. And so it's a mortality risk that outstrips everything else we've ever measured, really, in respiratory illness. And so to predict with PM 2.5 the mortality of a virus, we have to ask what's the relationship there and why this hypoxia. It turns out that viruses from influenza to coronavirus can bind to PM 2.5 in clusters. Remember, I said that when we see adaptation dysfunction or an abnormal response to viromic update, it typically heralds a change in our relationship or the change in the terrain of the human body. Certainly the pharmaceutical stuff that we describe can change those receptors, but now imagine upregulated receptors from chronic lung disease or pharmaceutical induction with statins and ACE inhibitors and the rest, interacting now with PM 2.5, high carbon particulate in the atmosphere that clumps the virus together to deliver overly concentrated amounts of genomic information. By this, you can overwhelm then those genomic regulatory functions of the enzymes and ultimately antibody response and everything else and create that illness downstream. But it turns out that PM 2.5 nor the virus are capable of producing hypoxia on the front end of this illness. What is classic for creating this histotoxic hypoxia, as it's called, is cyanide. There's also probably 64 to 100 other compounds that are typical in air pollution that can also participate in this injury. But cyanide is a classic example of hypoxia-inducing compound that happens to be able to bind to PM 2.5. Cyanide poisoning presents with blue patients, hypoxic, multi-organ failure from that hypoxic injury, and then downstream blood clotting and events with cardiovascular stroke or heart attack or deep venous thrombosis and pulmonary embolus and multi-organ failure and death. What I just described is the pathophysiology of death from what we've been calling coronavirus. But in fact, I believe that what's happening is we're creating these smart bombs by the combination of naturally occurring genomic information of the virus tagging onto PM 2.5 that then carries cyanide into the bloodstream. Cyanide, as it hits the bloodstream, then poisons the hemoglobin molecule, which is responsible for carrying oxygen throughout the body. When you change the shape of hemoglobin and you can't bind oxygen, it doesn't matter how much oxygen you pump in, you don't improve the hypoxia. And this has been recognized by many physicians on the front lines as the error that we're doing with our clinical medicine in putting all these patients on ventilators. They show up without enough oxygen in their tissues, so we say they're hypoxic, we need to get more oxygen in there, not realizing that it's not a lack of oxygen, it's a lack of oxygen carrying capacity that's causing the death. It's important for us to change our mindset as consumers and physicians away from this fear of viruses. Because when we just induce this fear, fight or flight, war-like state to a virus, we forget to think broadly about the clinical situations we're seeing, about the clear evidence that we're seeing that air pollution and soil pollution and agriculture are playing a very, very critical role in the mortality that we're seeing from this virus in the end. And so at both extremes, at the environmental stress level that would induce the production of viruses in the first place, to the downstream potential morbidity and mortality that's correlated with the viral presence, we have to come to terms with both extremes. It's human interaction, it's human destruction, it's human behavior that's mandating this global pandemic. We are really seeing a global pandemic of human life disconnected from Mother Nature. In our constant disconnect, in our constant failure to respect her exquisite balance and capacity for balance, we continue to create bigger and bigger discoordinate biologic events around the planet and within our own bodies in our inability to balance with the virome. And so this experience today, together, as we come around this topic of the virome, is an opportunity for us to look not just into the microbiome, not just into its communication with the greater ecosystem and greater multicellular life on Earth through that virome, but really to take a deeper look at what are we doing as humans? What have we done on so many levels to put ourselves in conflict with Mother Nature? And what can we do to reinvent human life, society, politics, and the rest to put ourselves in alignment with soil, water, and air systems? If we take the necessary steps to start to realign our energy and transportation systems, clean up the air, we will see an immediate drop, not just in coronavirus-like pandemics, but in the annual flu season. It's profound to realize that just as we've described with the PM 2.5 and coronavirus, we don't see flu season start until the third week of November every year in the United States. How is it possible that some new virus comes and attacks us in the third week of November every single year so predictably? And yet, you can map it down to the day of the year to see that event happen. What's actually happening in the third week of November to induce this whole phenomenon of flu season throughout the Northern Hemisphere? The answer, of course, lies in the soil. As the Northern Hemisphere goes into its winter months and we see a drop in the green organic growth above the soil and a quiescent state of the microbiome and the fungi and mycelium below the soil level, we see a massive reduction in the capacity of Mother Earth to reabsorb carbon. And so between the third week of October and the third week of November, satellite imaging and the rest shows an explosion of carbon particulate in the air. And that's tiny little carbon molecules of carbon monoxide, carbon dioxide, larger molecules like methane, all the way up to PM 2.5 exploding in the environment. At that moment, we change our relationship to all of the respiratory viruses in the explosion of that carbon content. We call it flu season, but in reality, it's carbon season. We are seeing an imbalance in our ecosystem of carbon particulate and its binding and carrying of genomic information that should be dispersed in an even, balanced homeostasis state with the human population, and we throw it into an unbalanced system of clumped viruses, too much genomic information per cubic meter of air breathed, and we see respiratory season kick in. Amazingly, as you see spring come on, Mother Nature has our solution. The green life that explodes over the courses of April and May will neutralize that carbon content such that by the end of June, we've completely eliminated that massive red cloud of carbon dioxide, carbon monoxide, and even methane and the like. We've reduced it by 96, 98% just over those 4 to 8 weeks between May and June. And suddenly, flu season is over. And so this thing that we call flu season, we need to start to come to terms with is actually human toxicity season. This is the season where we have superseded the planet's capacity to absorb the toxins we're constantly producing in the carbon atmosphere, and we are coming into an abnormal relationship to the virome. And so I want you to free yourself up of fear and start to think about your interaction with not just the virome, but also the microbiome, bacteria as a foundation for life, not an enemy to your body or to your children, and start to envision what would it take to put you and your family in a balanced state. And I believe it's more of this. If we spend more time outside, we spend more time breathing real air, we start spending more time in environments that are not heavily contaminated with municipal transportation and energy systems and particulate matter, if we spend more time on real soil systems and non-stressed, animal husbandry and the rest, we will come into a natural balanced state with not just the microbiome, but the viromic genomic information of life around us. We will become adaptive again. We will become creative, co-creative species within Mother Nature, and we will stop doing the harm that we have done through every sector of the consumer package industry, transportation, technology, and beyond. Thank you for your attention to the virome. I appreciate your opening up a possibility of finding beauty in this thing that we call the virome rather than fear. As we shift our reality from one of fear of Mother Nature to one of recognizing its beauty and its desire to co-create with us, we will change our macro behavior. And so I welcome you into a future where we align all of our human behavior with this extraordinary nature around us.